Hello, I'm Jack Koenig with Graco Industrial Lubrication Equipment. In this video, I'm going to demonstrate how to connect the GLC X controller to a Compact Dyna-Star that is configured for a series progressive divider valve system, which means we're also going to need to learn how to connect a proximity switch. So let's see how that's done. In that previous video, we were dealing with this cable that we sometimes call the Medusa, which is the wiring harness for the CDSs that have a vent valve and a pressure switch. And when you have the vent valve and the pressure switch, you end up with 4 connections total. But because on a series progressive divider valve system, you don't use a vent valve and you don't need a pressure switch, you only need 2 cables. So instead of making a harness, this is what ships with these pumps that are specifically for divider valves. You get a Deutsch connector cable that is going to connect here to the motor, and then you get an M12 cable that connects to the low level. And these M12 cables, sometimes they're black, sometimes they're gray. We change suppliers from time to time just to be smart shoppers. So either way, you may get a black one, you may get a gray one, but you just have these 2 cables to connect. So we're not necessarily required now to connect to a 12-pin Deutsch connector because the pump doesn't come with one. But that's still one of the easiest ways to do this. So I'm gonna start by demonstrating that. Another option is to just strip the wires and solder them directly together. And then the other thing is one way or another, the whole point is to get into this amp seal connector. And we do have kits for that, where we could connect our proc switch and everything else that we want to connect right into an amp seal via this kit. We'll get to that later in the video. Let's start by actually making a 12-pin connection wiring harness, just like we had for the single line parallel systems. And as I go, I'm also going to be following this guide that you can get from Salesbook. If you navigate to the pumps and then Compact Dyna-Star, there is a folder under Compact Dyna-Star for wiring diagrams. And right now, as I film this video, there are 2 diagrams available there. We're going to be adding more in the future, but this is one of them, and it actually shows you how to do exactly what I said we're going to do now, how to make a 12-pin Deutsch wiring harness for your series progressive system. We're going to be building on that previous video where we already added the female Deutsch DT12 connector to our 20-foot cable. This video could also apply to working with that 3-foot cable that we sell with the connector on it already. But now we're going to use our kit that comes with the mating male connector. It's the black one with the keyways that made up to this guy. And when we're revisiting the subject of crimping these DT terminals, the pins that we sell are designed to receive anywhere from a 16 to a 20 gauge wire. In my experience, most M12 cables are actually a 22 gauge wire. So what we need to do now is strip about twice as much. So you're looking at doing about 1/2 inch or about a centimeter, and you need to fold it over. So once we have this fold, now there's enough material that when we slide our pin on and crimp it, it's going to stay put. So it's really just to make sure there's enough material there that the crimper can give the terminal a good grip on the wire. So there, it took a little bit of playing around to get that fold to go in right, but now I'm ready to crimp. And now that's not going to pull out. That's on there really firmly. You can see I already clipped the white wire off because we won't be using that, and I'm going to go ahead and crimp the other ones. Now we are ready to build our harness. If you want to use that boot that gets included with the kit, remember to slide it on at this stage. I'm not going to mess around with that on this one. And now we have 2 M12 cables. Mine happen to be black for low level and gray for the proc switch, but yours might be the same color, so you're going to also want to consider labeling each end of the wire. And then we're going to be consulting this wiring diagram that you can get on Salesbook. So to that point, you may want to just pull it up on your laptop like I'm doing here, or if you're out in the field, have it on whatever smartphone you have, but you're going to have to do a lot of zooming in and out. So a tablet would be nice for that, but otherwise just bring your laptop out if you want to save this on your computer as a local file. And so we're back to the same quandary we had in the last video, where we know that 1 and 12 are on one of the corners. but we don't know necessarily which perspective we're supposed to be looking at. We can just mate up the other cable. And did I get that right? Yep, this is how it goes. I don't want it to click in though, because that might prevent me from actually being able to push my terminals in. So I'm going to pull that back out and just set it on here loosely. But now we can see that violet is number 12. So now we know as we're looking at this that we have 1 on the bottom, 12 on the top. Pin number 1 is the brown for the low level. So we're going to take our black M12, get our brown, and go into pin number 1. Now, these wires are so thin that they're going to be really hard to push through. So this is where the DT pick can be handy, or a small screwdriver. But you want to be careful that you're just getting the edge of that pin and not pushing into that wire. But now I got that in there all the way and it's seated. Number 2 is the blue for the low level. So that's convenient that they're all right in a row. So again here, I'm going to do what I can with my hand, but now I need to use my Deutsch pick. And these yellow pieces are just the packaging material. I leave them on there because I like having something to hold sometimes. But if you're wondering what's so strange about my Deutsch pick, it's nothing special other than I just leave those packaging material on there. Now the black is number 3. I actually want to keep doing the M12 cables because it's easier to do these first so that the rubber isn't squeezed around them at all, because if the one next to it is compressing it, it's going to make it even harder to slide in. So I'm going to wait and do my power cable last. So now we know that this is 1, 2, 3, which is actually upside down from the way you end up looking at it on the screen here. It's really from this perspective. So now, keeping in with my mirror image, that means number 6 over here is my blue for my proc switch. You can see this different brand of M12 cable. The blue is a different shade and the brown might be a little bit off too. So you can just see, even though they're different brands, these wire colors are pretty standardized on these M12 cables. And then number 7 is brown. And black is going to be way over on number 11. Now, what do we have left? We have our power cable. So all we need to do now is know that brown is positive and blue is negative on the power cable. And this actually just goes right next to the 3 that we started with for pins 1, 2, and 3. The positive is number 4. These ones we don't need the pick because there's enough wire there. And then the negative, or blue, is number 5. If you ever take apart one of the harnesses that we make, the Medusa harness that we like to call it, those use actually a black ground and a white positive voltage. But when you get these DT cables separately, it's going to be brown and blue. So now the one last step on this end is that we still have 4 open spots that we want to make sure we put plugs in. So that's where these white plugs come in that kit, is that these holes are open whether you put anything through them or not. So that's a water ingress issue, and you want to make sure that these get plugged. And then at this point, we would want to slide our boot up. And I left these wires way too long to use the boot anyway. So that's one other thing to consider. If you're doing the boot, make sure that you trim your wires so that you don't have so much wire hanging out from the jacket around the outside of it. So that's that. And now we just slide in our wedge lock. And this one's done. I was able to get my thumb in there because of the missing pins, so I could actually seat the wedge lock with my finger instead of having to force it with this. But that's what our wiring harness is going to look like for a series progressive pump, where all we're doing is the motor power, the low level, and the proximity switch. So now let's test our harness. I have the controller hooked up to the 24-volt power supply that we sell. Now let's plug in. I have the 3-foot cable on here. Click that in there. Really, the best way to test the motor connection is to hook it up to the pump and see if it runs. Looks like that's good. I hear the motor whirring up. I'm actually going to unhook this now. To test the low level, I put a second proc switch on. So my actual proc switch, I have one of these old mechanical ones so I can just press it with my finger. And then for the low level, I set my controller to alert. And also, while you're in there, speaking of the settings, one thing I want to show you on the settings is that if you're doing a series progressive system and you're not using a vent valve, and you're also not using the alarm output, it's best to just turn it off if you're not using either of those. Because I did not incorporate an alarm into this harness, I'm going to set this to none and I hit accept. And that's important in case there is a little water ingress or something. You don't want to send voltage to those pins unnecessarily. So that's just kind of a best practice. But other than that, I was in mode and I set the mode to cycle. And we're gonna be able to now test our switch. So let's hit manual run again. Now the controller is running and I have my proximity switch. There's 1 count, 2 counts, getting our counts. So that's great, the proximity switch works. And now the low level circuit, because I put a switch on this too. I also went in and set this up as an alert instead of an alarm. And there, we get our orange light coming on now to show it's the alert. When I let go, we can watch in there after a second or two, the alert turns off. There it is again, it's an alert. So even if you're setting up this harness to work with an analog transducer out in the field, you can temporarily test it on a controller that's programmed just to look for a switch and an alert on the low level, where once you have it out in the field, you want to make sure your controller is set up to the actual pump you have. But anyway, that's enough about testing for the moment. We know that this is a good wiring harness now, and it's ready to be used out in the field. I've said it before, and I'm going to say it again. On mobile equipment, do not use solderless butt connectors. These are not good for mobile equipment because they're not reliable. Especially now when we're getting into using analog sensors and such, we want to make sure we have a good connection. So I'm going to use a soldered butt connector here. I gave my wires a little bit of a twist. I had to strip them back a little bit further, but I'm gonna start with black and red because I know those are the power for the pump, and I already know that brown and blue are my positive and negative respectively. So brown's gonna go to red. One of the keys here is when you have some of these also already attached, you wanna keep them away from the heat gun. I kind of prep my wires here in advance. Now that's pretty good. I'm gonna lay it down, and now I'm actually gonna just take my heat gun and hit it from the top to make sure that everything melted up here too. There, I think that one's good. Now the other thing about a heat gun is we have to give it a few seconds to let that one cool and get a little stiffer before we move on to the next one. Otherwise it's just gonna make a big mess. I just repeated the same step with the blue to black and got those soldered together nicely. It actually went a little bit faster because the heat gun was already warmed up. But now we're going to need a wiring diagram. And I still want to use this one from Sales Book because it has a wiring diagram here, but it also allows us to see what color goes where because we can just match up the numbers. So even though we're not using the Deutsch connector anymore, we can see that here on our low level, we're going to be on pins 1, 2, and 3. So we know that we need the orange, we need green number 8, and we need the brown. So this is still a valuable guide even when you're not doing the Deutsch connector. Let's grab our orange. One other thing I wanted to note is that even though I just showed you that you want to disable the alarm output and the vent valve output in the controller itself, this white wire is what actually gets energized with the positive voltage. So instead of just clipping this white wire off, it's better to tape it down and really make sure that you don't have any conductor exposed. So now back to our orange one, we can see that orange goes to brown. These connectors now are a little bit smaller and they barely fit over my wiring harness for the GLCX. In fact, I can't even slide the other end all the way on. So I have them laying on there to kind of have them laid out for this process and also to orient the ends to make sure I can put this together. But at this time, we're going to want to slide this down onto the mating small wire. And then let's do our twist again here because that does help quite a bit. You'll actually get a better finished product because it will be straighter and not all gnarled up. All right, that's in position. Let's get the heat gun going again. Okay, everything's pretty good and melted from that side. I'm gonna set it down again like I did the bigger ones. And, oops. Now it is still pretty gooey, so I don't want to pull too hard. That's why I was saying earlier, this ends up being kind of a three-handed job. It pulled apart a little bit, but all right, I'm gonna let that cool. So the next things that we're gonna have to do is connect the blue here to green number 8, and then black's gonna go to brown. So I'm gonna do that, and I'll come back in a moment. Moving on, now we need to look at pins 6 and 7, which are the other green and yellow. And then we need to look at pin number 11, because that's the third one for the proc switch, which is gray. So now we have green to blue, yellow to brown, and gray to black, which is kind of neat because they're almost like different shades of the same color. So slate being more of a light black, and then green being similar to blue, and yellow and brown are kind of a common color too. So I'm just going to hook those up now, and I'll be back in a moment. Okay, this is all done now. Let's hook this up to a controller and just verify good signal. All right, we're ready to run another test. So I've got the motor hooked up right now. I'm going to hit manual run. I hear the motor running, so we've got that connection good. And now I'm going to do my proximity switch test. So I'm going to hit manual run. We're getting our counts, so that looks good. All right, we got all 10 counts. I'm going to hit manual run again and test my low level switch. I'm not getting a light on my switch. After a few minutes of troubleshooting, I figured out it was the orange wire all along. This was one of the first ones I hooked up, and I don't know if you remember, but it kind of slipped and pulled apart when I was working on it, and I thought that the solder was still making a good connection in there, but it turns out it was not. So I had to get out my multimeter, and this is where, again, the chart's handy, because number 5, I could see here in my connector, I can also see the wire right here, put one of my terminals there, and then on my M12 cable, I actually had to go find a little pin. This happens to be a DTP pin for a smaller Deutsch set, and that's pin number 1 right there. And now we have good continuity. So now I know my wire repair is good. I'm gonna put this all back together and we can test it again. Now I'm gonna hold down here. It's lighting up. And there's our amber light. So now I'm gonna take this switch and open it again. And now the amber light goes away. So again, this is just the alert behavior because I didn't wanna have to clear a fault. Now we can see how this is all done. I'm gonna put some shrink wrap on it and show you the finished product. And at long last, here we have our completed wiring harness with the shrink wrap to protect those wire leads. And yes, it's a long piece of shrink wrap because I had some pretty long wire leads to allow me to work with that heat gun. At this point, the process is done, and let's move on to connecting directly to the amp seal connector.